Hello viewers, in this video I'll be discussing about linear programming. First we will see the meaning of a linear programming problem. A linear programming problem is concerned with finding the optimal value of a linear function. This optimal value can either be the maximum value or the minimum value of a linear function. The linear function is called the objective function of several variables, say x and y, subject to the conditions that the variables are non-negative and satisfy a set of linear inequalities called linear constraints. So it is nothing but it is a problem of finding the optimal value of the objective function subject to certain linear constraints. So this is basically a linear programming problem. All these terms will be easily understandable after doing a few problems. Now let us see the second problem of exercise 12.2 in the class 12 textbook. The question says, one kind of cake requires 200 gram of flour and 25 gram of fat, and another kind of cake requires 100 gram of flour and 50 gram of fat. Find the maximum number of cakes which can be made from 5 kg of flour and 1 kg of fat, assuming that there is no shortage of the other ingredients used in making the cakes. So here they have given, that is, we have to find the maximum number of cakes which can be made from 5 kg of flour and 1 kg of fat. Additional information they have given is, one kind of cake requires 200 grams of flour and 25 grams of fat, and another kind of cake requires 100 gram of flour and 50 grams of fat. Now let us take the number of cakes of first kind be x. So let us take, let number of cakes of first kind is x, and let number of cakes of second kind is equal to y. Now what we have to find? We have to find the maximum number of cakes which can be made. So we have to find maximum value of z is equal to x plus y. So we have to find the maximum number of cakes of two kinds. So this is called the objective function. So what is our objective, or what is our aim? That is our objective function. So maximize z is equal to x plus y is our objective function. Now what are the other details that are given? One kind of cake, that is the first kind of cake, requires 200 grams of flour and 25 grams of fat, and the second kind of cake requires 100 gram of flour and 50 gram of fat. So I am writing here, we have cake 1, the first kind of cake, and the second kind of cake, and then flour required per cake and fat required per cake. So the first kind of cake requires 200 grams of flour. And the second kind of cake requires 100 grams of flour. The first kind of cake requires 25 grams of fat. The second kind of cake requires 50 grams of fat. Now, they have also said find the maximum number of cakes which can be made from 5 kg of flour. Here we have the flour per cake required in grams. So we are converting this 5 kg into grams. So we are having the constraint as only 5 kg of flour. So this is less than or equal to 5000 grams. And another condition given is they have only 1 kg of fat. So this 25 grams of fat required for cake 1 and 50 grams of fat required for cake 2 should be less than 1000 grams. I am converting 1 kg into 1000 grams. So here we have to find the maximum number of cakes. So we have to maximize z is equal to x plus y. This is our objective function and we are having certain conditions. So we have to write subject to the constraints. Constraints means conditions. Subject to the constraints. Cake 1 requires 200 grams of flour and cake 2 requires 100 grams of flour and the amount of flour available is 5000 grams. So we have 200x plus 100y less than or equal to 50. This is our constraint less than or equal to 5000. This is our constraint with respect to flour. So we can simplify this 2x plus y less than or equal to 50. Then the next one is the constraint with respect to fat. So cake 1 requires 25 grams of fat and cake 2 requires 50 grams of fat. So we have 25x plus 50x less than or equal to 1000. Or we can simplify this as, that is 25x plus 50y less than or equal to 1000, x plus 2y less than or equal to 40. So this is 1, this is 2. And then we have another 2 more constraints called the non-negative constraints of variable x and y. Now, we cannot make negative number of cakes. So, the value of x and y have to be non-negative. So, x greater than or equal to 0 and y greater than or equal to 0. This is inequality 3 and this is inequality 4. So, these two are called non-negative constraints. So the given problem can be written as maximize z is equal to x plus y subject to the constraints 2x plus y less than or equal to 50, x plus 2y less than or equal to 40, x greater than or equal to 0 and y greater than or equal to 0. This is how the given statement is formulated. This is called mathematical formulation of the given linear programming problem. Now we have seen a few terms like objective function, constraints, decision x and y. Now we will see what are all these, the meaning of all these. We just now saw the objective function. So from there we can write objective function is a linear function z is equal to ax plus by where a and b are constants which has to be maximized or minimized. In the problem that we discussed, z has to be maximized, but whereas there are other problems where z has to be minimized. For example, if z is given in terms of cost, then it has to be minimized. The next one is decision variables. The variables x and y which we just saw, those variables are called decision variables. The next one is constraints. Constraints are nothing but the conditions or the linear inequalities or equations or restrictions on the variables of a linear programming problem. These are called the constraints. The conditions x greater than or equal to 0, y greater than or equal to 0 are called non-negative constraints. Next, let us see what is optimization problem. A problem which seeks to maximize or minimize a linear function subject to certain constraints as determined by a set of inequalities is called an optimization problem. So, here we have to find the value of x and y such that our z, our objective function, is maximized or minimized. So, linear programming problems are special type of optimization problems. Now we will continue with this problem. So, the given question, we have written the mathematical formulation. This is called mathematical formulation of the linear programming problem. So, the given question can be written as maximize z is equal to x plus y subject to the constraints 2x plus y is less than or equal to 50, x plus 2y less than or equal to 40, x greater than or equal to 0 and y greater than or equal to 0. So, the first step in a linear programming problem is the mathematical formulation. So, we have formulated the given linear programming problem. The next step is to solve the linear programming problem. There are various methods available to solve linear programming problem. Among those, we are going to use only graphical method. So, in this graphical method, we use a graph sheet to find the feasible region. Feasible region is nothing but that region in which all these constraints are satisfied. So, we have to first take a graph sheet and mark the x-axis. 0 here. Here we have the x-axis, OX, and here we have the y-axis, OY. And then we have to solve all these. We have to draw all the lines of the given inequalities. Now first, let us take the first inequality. Let me mark this as 1. So, I have to draw the line corresponding to 2x plus y equal to 50. So, for that what I am going to do is taking x and y. When x is 0, the value of y is 50, and when y is 0, the value of x is 25. So, on the graph sheet, after marking the x-axis and the y-axis and the intervals, I am taking 10, 20, 30, 40, etc. because here I have 50 and 40, and on the y-axis also I am taking 10, 20, 30, etc. Now, I am marking these points. The first one is 0, 50. So, the point corresponding to 0, 50 is this point. So, this is 0, 50. The next one is 25, 0. The point corresponding to 25, 0 is somewhere here between 20 and 30. So, this is 25, 0. When we join these 2 points by a straight line, we get the line corresponding to the equation 2x plus y equal to 50. So this is the line which corresponds to 2x plus y is equal to 50. The next equation, the next inequality is x plus 2y less than or equal to 40. So let me take when x is 0, y is 20, and when y is 0, x is 40. So the point corresponding to 0, 20 is this point. So this is 0, 20, and the point corresponding to 40, 0 is this point 40, 0. If we join these 2 points with the help of a straight line, we get the equation of the line x plus 2y. We get the line corresponding to the equation x plus 2y is equal to 40. So this is the line. It is important for us to write the equation of these lines on the graph paper. So this line is 2x plus y is equal to 50, and the equation of this line is x plus 2y is equal to 40. The next two inequalities corresponding to x greater than or equal to 0, y greater than or equal to 0 is nothing but x is equal to 0 is our y axis and y is equal to 0 is the x axis. So now we have to find that part or that region in which all these inequalities are satisfied. Here, now let us take x greater than or equal to 0. X greater than or equal to 0, here all the values of x are positive. It corresponds to this part. Then y greater than or equal to 0, it is this part. Then 2x plus y less than or equal to 50. It corresponds to this part. Then x plus 2y less than or equal to 40 corresponds to this part. So the region which is common to all these constraints include this part. So this is the region where all the constraints are satisfied. Now it is important for us to find the point of intersection of these two lines. That is this point. This point we have to find. If we want to find this point, we can find it by solving these two equations. So I am writing it here. 2x plus y is equal to 50 and x plus 2y is equal to 40 as 3 and 4. Equation 3 into 2 gives 4x plus 2y equal to 100, and equation 4 is x plus 2y is equal to 40. So when we subtract, I get 3x is equal to 60 or x is equal to 20. Substituting x is equal to 20 in 3, I get y is equal to 10. So the point of intersection of these two lines corresponds to 20, 10. So here this is the feasible region, or this is the region where all these constraints are satisfied. So this is our feasible region. The shaded part is the feasible region. Now what is our objective? Our objective is to find the optimal value of z. How to find the optimal value of z is the next step. So we will see the meaning of feasible region, feasible solution, optimal solution, etc. So the feasible region is each point in this region represents a feasible choice. Therefore, the region is called the feasible region for the problem. Now, what are feasible solutions? The points within and on the boundary of the feasible region represent feasible solutions of the constraint. We call these feasible solution because all these points will satisfy the given constraints. Any point outside the feasible region is called an infeasible solution because that point will not satisfy the given constraints. Next one, optimal solution. Here optimal solution is any point in the feasible region that gives the optimal value, that is maximum or minimum value of the objective function. That point is called the optimal solution. So we have one theorem which says the optimal value must occur at a corner point or vertex of the feasible region. So the next step is to find the optimal value. So we have the feasible region and we have marked all the corners of the feasible region. The various corners are O, A, B and C. So here I have a table and the table has the vertex of feasible region or corner point on one side and corresponding value of Z is equal to x plus y on the other side. So let us take various vertex and the corresponding value of Z. I am taking the first vertex O, 0, 0. So the value of Z corresponding to the vertex O is Z is equal to x plus y, that is 0 plus 0, it is 0. Next one is A, 0, 20. So the value of Z corresponding to 0, 20 is 0 plus 20. So it is 20. The next point is B, 20, 10. The value of Z corresponding to 20, 10 is Z is equal to 20 plus 10, it is 30. Next one is C, 25, 0. The value of Z corresponding to C, 25, 0 is 25 plus 0, it is 25. So our objective is to find the maximum value of Z. The maximum value of Z is equal to 30 and it occurs at B. That is when the value of x is equal to 20 and y is equal to 10. It is not always necessary that the maximum value will occur at the point of intersection. It may occur at some other corner points also. So we have to look only for the maximum value of Z. So this is our answer. So the maximum value of Z is equal to 30 at x is equal to 20 and y is equal to 10. That is, it means the required number of cakes of first kind is equal to 20 and the required number of cakes of second kind is equal to 10. I hope this video was useful for you. Thank you for watching.